Welcome back to another lesson in MCR3U. Today we'll be looking at the combinations of transformations, specifically in terms of a radical function. So here we see this is the general form for transformations for any function. So here we have y is equal to a f of k x minus d plus c. And here we see that in terms of a, we say that it's stretched vertically by a factor of a. So we can stretch vertically by a factor of a. If a is less than 0, so which means that it would be a negative number, it means that it would be reflected in the x-axis. Here, in terms of our k-value is, again, stretched horizontally by a factor of 1 over k. So that's important here. So again, it's stretched horizontally by a factor of 1 over k. If k is less than 0, or a negative value, then the graph is reflected in the y-axis. One thing to notice here is that, again, the k value is factored. So here, okay, notice, again, k is factored. Okay, so now let's look at our translations. So here, again, it is, if we look at our d value, it's translated horizontally, d units. And remember, it is the opposite direction to the sign for d. So again, here, opposite direction to sign for d. And so here, again, if the operation is subtraction, the graph shifts to the right. And then if the operation is addition, the graph shifts to the left. So here, and then finally translated vertically in terms of the c value, c units. Again, if c is positive, the graph will shift up. And if c is less than 0, the graph shifts down. So again, here, the d value, again, translates horizontally, and the c value will translate the function vertically. So remember here, the order of the transformation matters. So remember, we looked first at reflections, then stretches and compressions, and then finally translations. So here, let's look at, again, the sketching the graphs of transform functions. So here we have our parent function of square root x. So given the graph of f of x is equal to square root x, state the transformations in order needed to graph g of x. So this would be our transformed function is equal to -2 f of x minus 3 plus 4. So here, this is the transformation that is applied specifically to this parent function. Then, starting with the base function, graph the transform function. Then we want to determine the domain and range. Okay, so the first thing here we'll do is we'll list the transformations in our correct order. So here we see that there is a reflection to start. So here we have a reflection. So reflection in the x-axis. The reflection in the x-axis. And then we see if there's any stretches or compressions. And we see here that it is vertically stretched by a factor of 2. Vertically stretched by a factor of 2. And then finally, we look to see if there's any translations. And here we see that it is, again, translated 4 units up. And we see that it is translated 3 units to the right. Remember, it is the opposite again of the sign that's there. So here it's x minus 3, so which means that it moves 3 to the right. Okay, so now we're going to use, again, our mapping notation. And so here, the transformations that affect the x value here are simply just that it moves 3 to the right. So here we have x plus 3. And then the values that affect the y value, first the reflection in the x-axis, so negative 2y, and then translated for units. So the reflection and the vertical stretch will affect the y value and the translation for units up. So here we'll plot again our x and our y values for our original function. Again, this would be our f of x is equal to square root x. So here we have 0, 1, 4, and 9. And then the corresponding y values will be 0, 1, 2, and 3. And then here we have our transform function, which is g of x is equal to negative 2 square root x minus 3 plus 4. And so here we have x plus 3 and negative 2y plus 4. So here, the corresponding x values and y values for the transform function will be 3, 4, 7, and 12. And then y values will be 4, 2, 0, and negative 2. Okay, so now we have a graph on the right here, which we can graph. So here we have first our original function of square root x, so 0, 0, 1, 1, 4, and 2, and 9 and 3. So that will be f of x is equal to square root x. And then our transform function, we have 3 and 4, 4 and 2, 7 and 0, and then off the page, which would be 12 and negative 2 to the round here. Okay, so this would be g of x is equal to negative 2 square root x minus 3 plus 4. Okay, so now it wants us to state the domain and range. Again, we can state it in two ways. Again, either through an inequality, again, or through interval notation. So here we'll start with the inequality. We see for, again, the transform function, x has to be greater or equal to 3. X is an element of real numbers. And our range, y has to be less than or equal to 4. And y is an element of real numbers. And so here in interval notation, and we see that it includes 3 and it goes to infinity, and it includes 4 and goes to negative infinity. So that would be our domain and range again for our transform function. Okay, so here it says using transformations and whichever method you prefer, sketch the graph of y is equal to square root 2x plus 4 plus 1. Reminder, the domain and determine the domain and range of the function. And here a reminder, write 2x plus 4 in factor form to determine the correct horizontal translation. So here again, we have to factor out the common factor of 2. And so our equation will be y is equal to square root 2x plus 2, and then outside the brackets, plus 1. And so here, again, let's state our transformations. So here we have a horizontal stretch by a factor of 1 over 2. Remember, it's 1 over k. In this situation, k value is 2, so 1 over 2. And then we have a few translations. Again, translated 1 unit up and translated 2 units to the left. And so here, let's plot some points here on our table of values. So here, and our original parent function will be y is equal to square root x. And so that's 0, 1, 4, and 9 for our x values. And then our corresponding y values would be 0, 1, 2, and 3. And then here for our transform function, which is y is equal to square root 2x plus 2 plus 1. Here we see, again, for our x values, it would be 1/2 x minus 2. And then for our y values would be y plus 1. And so here we get values of -2, -1.5, 0, and 2.5. And for our y values, we get 1, 2, 3, and 4. Okay, so now we can plot this transformed again graph. So we have -2 and 1. We have -1.5 and 2. We have 0 and 3. And we have 2.5 and 4. So look something like that. Again, this is our graph of y is equal to square root 2x plus 2 plus 1. And so now we're going to determine our domain and range. Again, so here our domain, x has to be greater or equal to 2. X is an element of real numbers. And our range, y has to be greater or equal to 1. Y is an element of real numbers. And again, here in interval notation, from -2 to infinity for our domain, and for our range, from 1 to infinity. Okay, so here, next thing we'll look at here is writing equations of transform functions. So here, the function y is equal to f of x has been transformed into y is equal to a f of k x minus d plus c. Write the following in appropriate form. So here, we have a vertical stretch by a factor of 2. Factor of 1 over 2. So here, that means, again, that our a value is equal to 1 over 2. Here, next thing we have a reflection in the x-axis, which means here that our a value will be less than 0 or would become negative, and then a translation 3 units to the right. So here, d is equal to 3. And so here for our transform function, we can write it as y is equal, sorry, a is negative 1 over 2 f of x minus 3. And in this situation, we're not given what our parent function f of x is, so we just write it in this general form. And here, the second example says a vertical stretch by a factor of 3. Vertical stretch by a factor of 3. That means a is equal to 3. Horizontal stretch by a factor of 2. It means our k value will be equal to 1 over 2. A reflection in the y-axis. That means k will be less than 0 or will be negative. And a translation left 5. So d is equal to negative 5. And then up 4. So c is equal. So here we write our transformations in. So y is equal to 3 f of negative 1 over 2 x plus 5 plus. And here again, remember that our k value is written factored out when we're given it in these values. All right, so let's take a couple more examples. Okay, so here we have, again, given the graph of f of x is equal to x squared. So here in this situation, we're looking at a quadratic. State the transformation needed to graph g of x is equal to 2 f of x plus 1 minus 1. Then start with the base function, graph the transform function. So here, again, let's just list our transformations first. So again, we have a vertical stretch, by a factor of 2. And we have a couple of translations here. Again, we have this function is translated 1 unit on the left and translated 1 unit down. So here, if we look at our mapping notation, yeah, be x minus 1 and 2y minus 1. So our parent function is y is equal to x squared. Here we have our x and our y values. So for x, we have negative 2, negative 1, 0, 1, and 2. And for our corresponding y values, we'll have 4, 2, 0, 1, and 4. And so here, for our transform function, we'll have y is equal to 2x plus 1 squared minus 1. So here, again, our x values, x minus 1, and y values, 2y minus 1. So we'll set those values in. We'll get negative 3, negative 2, negative 1, 0, and 1. And for our y values, we'll get 7, 1, negative 1, 1, and 7. And so here, again, we can graph the transform function. We'll start with the vertex at -1 and 1, and then again, it's symmetrical on both sides. So here we'll go 0 and 1, -2 and 1, -3 and 7, and 1 and then here, sorry, this would be, sorry, 0 and 1, and then 1 and 7. So it looks something like that, and that's our graph. Y is equal to 2x plus 1 squared. Okay, so here it wants us to determine the equation from the graph. And so this, again, our parent function we see here would be I is equal to square root x. Okay, and so we know here when we have y is equal to square root x, these are the points correspond with it. So x and y, so 0, 1, 4, and 9. And then our y value would be 0, 1, 2, and 3. Okay, so now let's look at this graph. So then we have a couple of points here. We have -2 and 3, we have -1 and 6, and then we have 7 and 12. Again, if we look at this original parent function, again, here it's usually from the origin, so it's usually over 1 and up 1. Okay, so here, usually over 1 and up 1. We see if we go over 1, instead of it only being up 1 now, it's up 3. So what we see is now we have over 1 and up 3. And so what does that tell us? That tells us that we have, again, a vertical stretch by a factor 3. Okay, so we have vertical stretch by factor 3. Then we see here when it was at 4, it's at 2. And so from the origin, when we move 4 over, so here that's 1. If we move 4 over, 1, 2, 3, 4. Let's see how much up it is. It's 1, 2, 3, 4, 5, 6. So here at 4, it's at 6. But see, originally we see that it was at 2. So again, see, we see that it's vertically stretched by a factor of 3. Then to just confirm for the last point, 9. So here, 5, 6, 7, 8, 9. If we go up, we see that it's at 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Originally it's at 9 and 3. Now again it's 9 and then up 9. So we see that 3 times 3 would give us 9. So again, we confirm again that there's a vertical stretch by a factor of 3. The easiest to see if there's any translations is to look at the point where this radical function would originally start, which is at the origin. Originally it starts at 0, 0. And so original function starts at 0, 0. Okay, now it's at -2 and 3. So here we see that it has gone left 2 and up 3. And so here we can write our equation. It would be y is equal to 3 square root x plus 2 plus 3.